ไฟล์เข้าไปที่อันนี้แล้วก็ว่าจะใช้ไหมครับอะไรจะดีใช่ไหมแก้วนี้เหรอเด็กชื่ออะไรเด็กชื่ออย่าง
ครับผมอยากเป็นเจ้าของโดนอยากเป็นเจ้าของโดนโอ้โหถามอะไร
คนตั้งไปแจ้งกรมที่ดินก่อนปิดครับห้องการกรใช้ปิดผมเรียกว่าปิดห้องนี้เขียนโอเคไม่ใช่ห้องนี้นะ need also to buy presentation. My God.
แต่กูปกติเปลี่ยนแล้วได้แต่เดี๋ยวเอาเดี๋ยวพี่แล้วก็ให้บวกให้แล้วอยากจะตัวไพ่ต่าง
22 points 12 points 23 เอ้าวิบูลย์กลับมาแล้วนึกว่าคุณจะลาด้วยวันนี้10 โอเคครับ
โย
โอเค the first one คณาวุฒิครับคณาวุฒิครับผมแป๊บนึงนะครับคนที่ใช้งานคณาวุฒิแล้วก็ชยากรคนตัวบกพร่องสูงไปไหนแล้วชยากรแอปเซนนะทันวินครับทันวินฮัลโหลทันวินนัทวัฒน์ที่จะพิเศษธนากรอยู่ไหนครับไม่เห็นมีอะไรให้ผมเลยอ๋อมันมีแบบว่ารายกลุ่มของอีพัทเนาะเขาส่งมาใช่ปะไม่ใช่ม.5 อันนี้มีแค่ม.5 ครับม.คุณไม่มีครับอะไรเนี่ยโอ้มีคนชื่อเดเลนฟูด้วยคนไทยหรือเปล่าโอเคมีไหมเอ่ยมีไหมคณะบุญมีใบไหมครับผมแอปเซ็ตนะธนากรโอเคครับธนากรการบ้านสังคมเสร็จแล้วหรือยังเรียบร้อยแล้วยาวมากก็พักครับพักหลับอยู่หรือเปล่าไม่เป็นไรไปปลุกเขาทำไมอ่ะเขาหลับไปแล้วก็ศิลภพอะไรแล้วศิลภพครับอันวินเพื่อนคุณศิลภพไปไหนแล้วศิลภพไม่อยู่แอปเซนต์นะครับคณะบุญไม่มีนะผมนี่นะแอปเซนต์ไปแล้วอันนี้วัดครับอันนี้วัดแล้วก็โรลวีเล็กซิปเข้าน้ำนะสารักโอเคครับสมาร์ทยังหาเสียงอยู่หรือเปล่าสมาร์ทอ่ะยังหาเสียงอยู่อ่ะมันหมดฤดูกาลยังไม่หมดหรอนี่เขาเขียนว่าระหว่างวัน12 ถึง 15 นี่มัน22 แล้ว เลยมา1 สัปดาห์แล้วยังมีหาเสียงอยู่แต่โรงเรียนไม่ได้แจ้งนะไม่ได้เขียนว่า22นะครับเอายังไงอ่ะพวกสมัครต้องถ่ายรูปมาแล้วถ้าเกิดว่าจะใช้10 ล้านนะให้บอกเพื่อนให้เขาถ่ายรูปมาว่าคุณไปหาเสียงห้องไหนอะไรก็ช่างอยู่ในโรงเรียนผมจะไม่ตัดคะแนนคุณแต่ถ้าไม่มีรูปผมถือเป็นขาดนะเพราะว่าในใบของโรงเรียนเขียนว่า12 ถึง 15เท่านั้นเนี่ยเขาเขียนถึง12 ถึง 15พวกเทศกาลหาเสียงอ่ะยกเว้นมีใบใหม่ที่ว่าลาถึง22ได้แล้วสมัครไม่มีนะผมแอปเซนต์ก่อนนะแล้วก็จีโน่ครับจีโน่ฮะไปกับสมัครอ้าวไม่มีใบลาอะไรงานแล้วก็แดนฟ้าปกติจะเดินลอยไปลอยมาแถวนี้ไม่มีเหมือนกันชยากรครับชยากรเดนิสเหลียวบูรินชยากรไม่มี
มาแล้วครับจากการเข้าน้ำ
คุณเยวีเป็นฟุตบอลมาเมื่อกี้นี้ภูมินันนักกีฬาเนาะกันเองครับกันเองติ๊กให้คุณแล้วจำได้แล้วไม่ติ๊กแล้วเพราะใบลาเขาเขียนถึงแค่ใบลาเขาเขียนให้10 คุณแค่12 ถึง 15นี่มันที่22แล้วครับจริงผมต้องย้อนไปวันพุธด้วยนะคนที่ลาหาเสียงอ่ะตีเป็นขาดนะเพราะว่าโรงเรียนไม่ได้ถ้าคุณจะใช้สิทธิ์ลาให้คุณถ่ายรูปมาเท่านั้นคุณไปอยู่ห้องไหนก็ได้ตรงใดของโรงเรียนก็ได้คุณถ่ายรูปมาธีรภพเอาโหผมเรียกนานแล้ว
ผมไปขี่
แดนฟ้าด้วยโอ้โหหายไปไหนคนผมเหนื่อยนะเนี่ยที่เขียนหลายรอบครับติ๊กให้แล้วปิดเคนัทนนท์คุณไม่ไปแล้วเหรอเริ่มไปแล้วเหรอคะแนนถึงแล้วนะโอ้คนผมยาวอ่ะจะไปเรียนกับใครเนี่ยโอเคทักกินครับถอดเสื้อโอเคครับปาทำเรียบร้อยเจ๋วมากครับกรินจีครับโอเคธนทรเอาโอ้โหเป็นกันเลยเหรอธนทร
ใช่กูยังไม่ได้ส่งเวลาลงเลย
สลบสลายจะไปกวนเขาแล้วเอาให้เขานอนพักผ่อนแล้วก็จะได้หายนะครับจะได้หายนี่ดีกว่าลาแบบป่วยนะมันนอนป่วยอยู่ที่โรงเรียนในห้องเรียนครับโอเคนฤทธิ์เล่นเกมว่าไงโอเคครับกาซิเดอยู่โน่นนะจะเล่นโกงหรือเล่นอะไรกันครับอ๋อเคยเห็นเพื่อนตอนปริญญาตรีเล่นกันอยู่แต่ผมศึกษาไม่เป็นแล้วก็ดูเขาเครียดน่าสนุกดีครับพัฒนนท์ครับพัฒนนท์มีโทรไปบอกเพื่อนด้วยนะพัฒนนท์ภูเมธครับภูเมธคนตัวใหญ่ไปไหนแล้วภูเมธตัวใหญ่ไปไหนแล้วนั่งเนี่ยครับไม่มีก็แอปเซนนะวิบูลคุณลาถึงวันไหนเนี่ย21วันนี้ไม่เกี่ยวเนาะ โอเควันนี้มาจริงขาดไปประมาณ 4-5 คนนะครับโอ้โหคุณมี 30 คนจะขาดได้ไงขนาดนั้น 4-5 คนเดี๋ยวผมแจ้งรีมายด์ดูก่อนว่ามีใครบ้างครับที่ยังไม่ได้จัดการคะแนนเรื่องคะแนนเก็บนะกูโคเขาเดี๋ยวแล้วชัยกรเดนิฟเกี่ยวอะไรด้วยชัยกรถ่ายรูปไม่เห็นหน้าหน้าเบอร์ไม่เห็นหน้าคุณอ่ะคุณไปเอารูปใครมาเนี่ยalright formative score right นี่นะคนที่ยังไม่ได้เวลามาถึงก็คุณทำอะไรวะแล้วคุณยังใช้อยู่ปะหรือว่าให้ผมถ่ายรูปก่อนไอ้ผมเก็บไว้เลยหรือว่าคุณมีเวอร์ชัน PDF เลยกล้องมันไอ้คือมือถืออันนั้นแล้วติดนั้นแล้วทำอะไรไม่ได้แล้วยกเว้นคุณถ่ายแล้วก็ส่งรูปไหมผมก็ได้ยกเว้นคุณจะเผื่อคุณจะไปใช้ลาคนอื่นด้วยอะไรเงี้ยผมจะได้แนบใส่ในไฟล์นี้ได้โอเคงั้นเดี๋ยวผมเก็บไว้ครับโอเคงั้นจบมีใบอันเนี้ยจบเลยไม่ต้องถ่ายรูปแล้วอย่างเงี้ย
มีใบไหม
โอเคwho else จะมีคนที่ผมเพิ่งยังไม่ได้เช็คอีกใช่ป่ะที่บอกว่าแสดง presentation นะกันเองเนี้ยพูดไปแล้วใช่ป่ะกันเองอ่ะคุณพรีเซนต์ไปแล้วใช่ป่ะแสดงว่าวิดีโอเขายัง YouTube ยังไม่ได้จัดผมก็เลยไม่เห็นไม่ได้ให้คะแนนพวก
ใช่ไหมเนี่ยยังไม่
ปาดคำก็ไปใช่ป่ะ
ใช่ครับ
ปิดจีก็ไปแล้วเนาะ
ใช่ครับ
นาริศไปยังแล้วคุณจะไม่พรีเซนต์ใช่ป่ะคุณจะเอาศูนย์ใช่ไหม
เราสูงนาริศคงเด็ด
ผมอายุเยอะแล้วถึงโลกเยอะผมไม่ได้แล้วถ้าสัก10 ปีที่แล้วยังไหวอยู่เดี๋ยวนี้โลกมันมาแล้วครับยังมีชยากรตรงสูงอ่ะไปพรีเซนต์ไปแล้วเนี่ยนัทวัฒน์เนาะยังเนาะศิลภพพรีเซนต์ไปแล้วใช่ป่ะศิลภพไปแล้วใช่ป่ะเดี๋ยวผมกลับดู YouTube เก่าไปคลิปเก่าเอาภาพหายanyway นัทวัฒน์มาเริ่มเลยครับเฮ้ยผมกดอัดยังเนี่ยหายแล้วยังไม่ได้กดอัดกดอัดแล้ววิ่งแล้วอะไร HDMI เจ๊งพอดีไม่ขึ้นครับคุณก็เปิดของคุณเลยทำไมไม่ขึ้นไม่ใช่โอ้ทาราลาห้องนี้เหรอทารา
พอดีห้องนั้นจางเขามาเนี่ยผมเลยมาเล่นกับเพื่อน
ติดป่ะเอาเกิดอะไรขึ้นเดี๋ยวคุณมันนี่ไฟมาเรียนโดนปรับเขาเลยทักเจ้าของห้องครับทำไมจอมันดับไปเลยครับคุณน่าจะเป็นผู้เชี่ยวชาญไง ทำไมไฟดับไปเลยเมื่อกี้ผมก็นะหายไปเลยไม่ทำให้ iPad ผมพังไฟไม่เข้าเลยนะครับเนี่ยอันนี้ก็ไม่นานนะเนี่ยไฟไม่มาเลี้ยงเลย
อ๋อจานมันต้องวัดกับวัดคือมันต้องอย่าง
โอ้ให้เขาทำตอนปีใหม่นี่ไม่ได้หรอหยุดหลายวันมีหน้าจอผมหายไปเลยเดี๋ยวผมนั่งดูก็คุณเอาไมค์ไปด้วยอะไรครับเอาได้เอาไมค์นี้ด้วยนะอัดเสียงของผมเลยไมค์นี้เหน็บกระเป๋าเสื้ออย่างเงี้ยไว้ด้วยประมาณนั้นติดแล้วสีฟ้าไม่ต้องไปกดอะไรครับติดแล้วไม่รู้พูดไปสัมภาษณ์ที่ไต้หวันมาเราไปสัมภาษณ์ที่จีนดูออนไลน์ก็ได้ต้องปิดตรงเลย
ไม่ไหวทุกคนเลยทุกคนฟังเลย
ไม่ได้ยินคุณเอานี่ก็เอา
โอ้ไม่ไม่โก้ว้าว
So today I'm going to present about Marie Curie and her work. The revolutionary in radioactivity by that was happened in number 5. So Marie Curie, born Marie Sklodowska, was a theoretic physicist and chemist. She was born on November 7, 1867 in Warsaw, Poland. She was born on November 7, 1867 in Warsaw, Poland, during the time when Poland was under Russian control. Her parents both educated, valued study more than anything, and encouraged their children to follow their path. Very early years were marked by a interest in knowledge, despite limited education, opportunity for a girl in Poland. She displayed exceptional intelligence and profound curiosity about the natural world. She attended an informal clandestine flight university in Warsaw, where passionate graduates provide education to Polish young under Russian rule. This early exposure fueled her desire to pursue higher education in science. In 1891, Marie Curie moved to Paris to study at the Sorbonne, facing significant challenge due to financial constraints and language barrier. Undetermined, she immersed herself in her study, excelling in physics, chemistry, and mathematics is what inspired that she met Pierre Curie, a physicist that soon married, forming a scientific partnership that would change the course of scientific theory forever. ไม่เป็น Marie and Pierre Curie delved into groundbreaking research on radioactivity and turned their coin on mathematical discovery. Their collaborative effort led to the three children. One is is polonium named after Marie Curie, the country that was born in Poland, and other is radium. And in 1903, they shared the Nobel Prize in Physics with Henry Becquerel for the groundbreaking work on radioactivity. But tragedy started in 1906 when Pierre Curie died in traffic accident, leaving Marie to continue her research legacy alone. She became the first woman to hold a professorship at the University of Paris and continued her pioneering work in 1911. Marie Curie received her second Nobel Prize, this time in chemistry, for her discovery of radium and polonium and her extensive contribution to the field of radioactivity. Marie Curie's legacy extends far beyond her scientific achievement. She shattered the gender barrier in science, becoming an inspirational figure for future generations of scientists, especially for women. Her life story embodied resilient dedication and unwavering commitment to scientific discovery, but she passed away on July 4, 1933, but her contribution to science and pioneering spirit continue to inspire and impact the world to this day. So let's talk about the application, the radioactivity. So, radioactivity is a natural phenomenon where certain elements undergo spontaneous and continuous decay, emitting particle and energy in process. At atomic level, unstable nuclei of certain elements have an excess of energy or an imbalance in the ratio of proton and 2 neutron. To regain stability, these nuclei release energy in the form of particle and electromagnetic wave. Okay. So the application. Radium discovered by Marie Curie was initially used in ballet application due to its radioactive property. In the past, it was utilized in luminescence particle for watch diode to make them grow in the dark.
Can you make it bigger?
Okay. Additionally, its radioactivity were thought to have potential medical medicine on cancer therapy and X-ray. However, due to its high radioactivity and associated health risks, its application has been diminished over time, especially in consumer products, and more controlled use in medicine and industry are practiced today. So the application of radium is radium-226 to radon-222 plus helium-4 and plus energy. The scientific equation describing the radioactivity decay of radium-226, a common isotope used in luminescence, can be represented as this decay of radium-226 emits alpha particle, helium-4 nuclei, and transform into radon-222. Releasing energy in the process, this energy is what excites the material in the wash. Light causes it to grow in the dark in the process known as radioluminescence. Thank you.
That's our
Question.
Is there any question who
Me, I have one question for you, Mr. Doctor.
ผมมีคำถามครับ
อันนี้เรื่องมารีคูรีนะ Do you think discovery of do you think the discovery of radium is significant to our world in the present?
Yes, because it has a lead field into medicine. It can be used in curing cancer, and also her work in radiology and radium contribute to creating X-ray technology.
Okay, thank you.
I can realize that she got the Nobel Prize in chemistry due to the discovery of
Polonium and radium.
Yeah, and what about the first Nobel Prize for her in physics with only Becquerel? What is the contribution to that?
I think it's when she met with Pierre Curie. I think it's around that. The story is something, but I didn't get the information. Sorry. พูดเรื่องประวัติชีวประวัติของมารีคูรีกับเลย
Okay. So when there is no more question, we're gonna finish. Thank you very much.
ผมไม่ค่อยชอบ
ไม่ได้ครับโตมาคุณต้องเป็นแน่นอนเพราะว่าใช่ครับมันมีเป็นการมันมีเดียวไม่ได้ครับผมต้องเป็นนายมากๆเป็นนายของคุณนะแต่เจอตายอย่างเงี้ยหลายรอบมันก็ต้องเป็นเองครับได้ครับคุณจะต่อแล้ว
คุยเรื่องอะไรก็เขามาบอกผมว่าเขาเป็นคนขี้อายเขาไม่ค่อยชอบพรีเซนต์เห็นดูมากอย่างนี้เดี๋ยวพุงออกนี่เดี๋ยวโตมาเป็นนักการเมืองแน่นอนเนี่ยแล้วคุณจะไม่พูดได้ไงนักการเมืองเนี่ยมันต้องพูดหาเสียงอยู่แล้วมากอย่างเงี้ยดูท่าทางจะมาบอกว่าขี้อายเดี๋ยวคอยดูเอาวางไฟเลยวางไฟในนู้นเลยโยนไฟไปเลยครับเอาไม้ใส่ด้วยใส่ไม้ด้วยมันอัดให้ผมฟังไงผมต้องไปนั่งฟังที่บ้านอันนี้ใครเอาไปหมายถึงนาริศเนี่ยนาริศต้องพิเศษนาริศยังไม่พิเศษเลยเสียบตรงปกคอเสื้อใส่ได้ที่หนึ่งที่คุณไม่เอาไม่ใช่ฟิสิกส์ผมนี่เป็นไฟฟ้าเลยหมายถึงว่าลวดเชื่อมกับตัวหมายถึงว่ามันมีกระแสไหลอยู่ในสองเส้นนะเราเชื่อมอย่างนี้เหรอเฮ้ยไอ้เหี้ยแท็กโก้คนที่ถามไม่ช้าตอบแต่ว่าอาจจะไม่ได้โอ้บอกแล้วว่าเป็นเร็วมากเอ้ยคิวใครครับบอสชอบตามชื่อใครบอสดิสคอร์ดเกย์ไออาร์ใครเอาไปเกย์ไม่เป็นที่ต่อเลยโรเดี๋ยวใครเข้าเล่นที่เล่นโรแล้วโอ้ยเล่นใครคุยแล้วไอ้คนนี้กูจริงจังนี่จะฝากบอกมาที่ฟอร์ดของคุณที่ทำไอ้โปสเตอร์เองหรือเปล่าหรือคุณไปโหลดไปยังไงครับโปสเตอร์เนี่ยที่คุณเฮ้ยโอ้ทำไงเขาไปหาโหลดจากเหี้ยอะไรวะมันมีเทมเพลตใช่ไหมข้อมูลโอ้ my god ใส่ต่อมันมีตัวอยู่นาพูดเลยครับอย่างนั้นแหละดังๆไปแล้วช่วยเสียงดัง
about quantum Hall effect. First of all, what is quantum Hall effect? Quantum Hall effect is a quantization of Hall effect, which is observed in two-dimensional electron system subject to low temperature and strong magnetic fields, which Hall system RXY exhibits states that take on the quantum value. Now, where V Hall is the Hall voltage, I cannot positional curve. E is the unitary charge and H is the Planck constant. The divisor V can take on either integer or fractional value. Now, the striking feature of the integer is that the quantum Hall effect is the persistence of the quantization. Example are Hall material, as the electron density is varied. Since the electron density remains constant when the Fermi level is a clean spectral graph, this situation corresponds to one where the Fermi level is energy with the finite density of state to reach localized. Now, the history behind it is the metal oxide semiconductor field effect transistor invented by Mohammad Atala and Darwin Khan at Berlin in 1959 involved physicists to study electron behavior in a nearly identical to the emission of gas. Or we'll call it as a MOSFET for short. Now, in a MOSFET, conduction electron travel in a thin surface layer and the key voltage control the number of charge carrier in this layer. This allows researchers to explore quantum effect by operating high purity MOSFET at liquid helium temperatures. Now the integer factorization of the Hall content was originally created by the University of Tokyo researcher Tsunya Ando, Yukio Matsuyo, and Yasutara Uemura in 1975. On the basis of their calculation, which they themselves did not believe to be true. In 1978, the Gakushin University researcher Junichi Wakabayashi and Shinichi Kawaki subsequently observed the effect in experiment carried out in this equation inversion layer of the MOSFET. Now this application is the quantization of the Hall content may have the important property of being exceedingly precise. Actual measurement of the Hall content have been found to be the integer or fractional multiple of e squared divided by h to nearly 1,000 billion. It has allowed for the definition of a new practical standard for electrical resistance based on the resistance quantum given by the Born-Christian constant, or RK for short. This name after the crosswalk crystal, the discoverer of the exact quantization. The quantum law can also provide an extremely precise independent determination of the fine structure concept and quantity of fundamental component in the quantum. And this is the reference.
That's it.
Yeah.
So is there any more presentation มีใครจะพรีเซนต์อีกไหมครับมีไหมเอ่ยมีคนไหนจะพรีเซนต์อะไรอีกไหมเอ่ยครับเช็คไปแล้วครับปูเมธคุณยังไงอ่ะคุณดูในกลุ่มไลน์ดิว่าคุณเป็นคุณขาดหรือเปล่าคุณดูในกลุ่มไลน์ผมน่าจะขาดปูเมธนี่ไงแอปเซนต์นี่ไงเอาแล้วห้องนั้นเขาไม่ได้เรียนกันครับห้องนู้นอาจารย์เขา
ไม่มีที่อะไรอะไรดีอ่ะรอบเสร็จแล้วเยี่ยมรู้แล้วแปดไม่ได้เยี่ยมมึงเล่นอะไรต้องกูไหมไม่เป็นแล้วต้องยอมเลยยอมเลย
Okay, in order to not lose our time, waste our time, we have start the chapter 7. Okay, that's the nuclear physics and particle physics, which is not included. This subject is not included in the midterm examination, so you don't have to worry about it. It's gonna be a part in the final exam. So let's start with that. This chapter would consist of two main topics. That's nuclear physics and particle physics. So in the nuclear physics, it would be a consequence of the previous chapter. In the previous chapter, we talk about the electron behavior, right, and electron orbit, electron shell, and so on. We're gonna get into the center or the nucleus of the atom, which is the which includes neutron and proton usually. And inside the basic particles, we're gonna see something that is even smaller than the proton and neutrons. That's called particle, elementary particles. Okay. The first topic is that we will talk about nuclear physics, and in the second part we're going to see something about particle physics. Nuclear science, that's the first quality we're going to study. And nuclear force, okay, and nuclear mass, and nuclear force is quite difficult because it's very complicated. So we will study only how it behaves. Only we cannot see them quantitatively, and nuclear mass will lead to the different mass or the mass laws, and then this will be converted to the binding energy. Next, we will see different types of radioactivity. It's going to depend on decay rate. We will see the alpha decay that's related to the alpha particle, which is the nucleus of helium-42 only, okay, without 2 electrons of helium. Beta decay will be composed of 2 categories. The first one, the first type, is the beta minus, and that's the electron emission, and beta plus decay will be positron emission. Okay, this one has a smaller particle than the nucleus of the helium-42. And another type, the last type of radioactivity is the gamma decay. These this ray doesn't have any particle, but it's kind of photon. And we are going to see the carbon dating, which is a topic about estimating the time of an object by using the decay rate of the carbon-14, which is an isotope, which is a layer isotope of the carbon-12 on Earth in the nature. And nuclear reactions, okay, will be the next thing we're gonna talk about. This can be decomposed into nuclear fission, which means we decompose a big nucleus to a smaller nucleus, and we're gonna have nuclear fusion, which happens in the opposite way. Smaller particles are combined together, leading to the bigger particle. That's called nuclear fusion. And in the second part, we're going to see 4 fundamental forces that exist in physics. And the standard model of elementary particles, okay, it will be, you have already seen this table before. Okay, we're going to get into more detail, and we will talk about quarks, okay, which is the first type of fermions. We will see leptons, which is the lower group in the fermion, and hadrons, which is a bigger particle that's the mix of those fermions. This includes mesons and baryons. Okay, that's it for this chapter. Okay, what is the meaning of nucleus? Nucleus means the core or the central part, and it has the round shape, which others as symbol means in this sphere it is made of several particles. What is the difference between nucleus and nuclei? Nucleus is the singular form, whereas the nuclei is the plural form of the nucleus. Okay. Nucleus is a collection of particles or protons which are positively charged, and neutron. This has the one positive charge, okay, of electron, and the next one is neutron. Neutron doesn't have any charge at all. It's neutral, as the name suggested, and nucleon. Nucleon is the general term or generic term that is used to refer either a proton or a neutron. In the nucleus, we're going to have the symbol like A on the superscript on the left, and Z as the subscript on the left. Okay, and X is the name of each element, and it might be often neglected. That's the number of neutrons. Okay, A is the number of nuclei, that's mass number, and Z is the number of protons. The reason why they call A F, the mass number, is that the electron mass is very, very small compared to the mass of the nucleus, so we can neglect the mass due to the electron. Even you have bigger elements, you have several electrons, the mass of electrons is still not significant when it is compared to the mass of the neutron or the proton. So A is the number of nucleons, the number of whether it is proton or neutron, and in the nucleus, those are called nucleons, the number of nucleons inside the nucleus. And Z is the number of protons, which is very important. Because if you change the number of protons, you're going to have different elements. Okay? The element changes. The number of neutrons can be also found from the difference between the mass number and the atomic number, the number of neutrons. If you subtract, it's going to give you the number of neutrons. For example, aluminum 2713. Okay. Of course, 13 is the number of protons in the nucleus of aluminum. And 23 is the number of neutrons, whether it's proton or neutron. They have 23 neutrons. So let's talk about this one. K atom, right? If you put a single proton, it's going to be ion in atom.
อันนี้จะอะไรกันไม่ได้
ฮะ
ถ้าเกิดมันไม่มีไอ้ตัวออปชั่นมันก็เปลี่ยนไป
เป็นไม่ได้ใช่ป่ะเช็คแล้ว
ถ้าเกิดมันมีไอ้ทรงล้ออันนั้นนะครับเปลี่ยนได้แต่ถ้าเกิดไม่มี
ไม่มีก็เป็นภาษานี้ไปเลย
ก็ให้มันเป็นดีฟอลต์ไปเลย
ตายทำไง
เดี๋ยวได้สบายก็ได้
Okay, so this is the hydrogen, right? And it's in the ion state because we still didn't have any electron. Okay, if you leave electron, yeah, it's gonna be simple hydrogen atom. And if you throw away that electron, it's gonna be only the nucleus of the hydrogen. ฮะ neutral atom ไง neutral. Now I try this at home. What starts up ก็คือ water stuff ไฮโดรเจนใช้เป็นสารประกอบในน้ำอย่างเงี้ยครับดีมาก if you put one more neutron, what is that? It's still hydrogen. Yeah, with one more neutron, and that's called deuterium. Okay, deuterium, because you have two neutron, single proton, but it's still the element of hydrogen because you have only a single proton. If you put one more proton, it's no longer hydrogen. It's not called hydrogen, or it's called helium. If you put one, and this is not in, it's stable. If you put one more neutron, you can have helium-42, right? And this is in the ion state because you didn't have the same number of electrons as the number of protons. This is helium-42. If you put one proton out of this, it's going to be still hydrogen, but with an additional. You can see that these nucleus vibrates. It means that the nucleus is not stable, unstable. It's stabil. Wasserstoff is the name of hydrogen in German. But if you want to get meaning, Wasser means water, stoff means material or something like that. Instable means not stable. Okay, yeah. This is tritium. Okay, tritium because the word tri means you have 3 nucleons, but it's still called hydrogen because you still have only a single proton. Okay, it's in the neutral state because one proton and one electron will leave the electron neutral. Okay, if you put 2 more protons, it's moved from hydrogen to helium and then later on to lithium. And this one is not stable. We're going to need to, because when the protons stay together, you're going to have repulsive forces, right? And this repulsive force will make the nucleus unstable. So if you want to let them be stable, you're going to need to leave for one. And this is lithium, 63. But it's still in iron because you don't have enough electrons. You need to leave one more electron. And that's stable. There is no vibration. Alright. Now. Like this. Okay, neutron. Proton. Okay, proton, neutron. Like this. Okay. This is in neutral state. You put one more neutron, it's going to be tritium. It's not stable. You put one more proton. That's helium-42. And it's stable, but it still has the ion state. You need to leave one more. So this is neutral. Okay. So you get some ideas about the atomic number and the nuclear symbol for aluminum. It has mass number of 27 because the number of either proton or nucleon would be 27, and the number of proton is 13. We often omit the subscript Z because it already implies the chemical symbol. Because if you work with the element every day, several elements every day, you would be able to recognize the number, you will be able to remember the number of protons in each element. Okay, the nuclei of protons of a particular element must contain the same number of protons. Okay, you cannot have different value of protons for each element. The elements would have the same number. A single element would have the same number of protons, but maybe different numbers of neutrons, and that's called isotope. It may contain different numbers of neutrons. That's the idea of nucleus. An example of the isotope is carbon. Okay, carbon would be carbon 11, carbon 12, carbon 13, carbon 14. Okay. Carbon 12 is the major isotope that we can find in nature. Carbon 13 is not easily found. It exists only 1.1% because when there is when there are too many neutrons that will make the nucleus unstable. And carbon 14, which is even more unstable. Because the decay of this unstable isotope, we're going to use its decay rate in computing the age of element. That's called carbon dating. Let's see how carbon 11, 12, 13, and 14 we have. Carbon. So it has 6 protons. 5 and 6 Polish stop. So if we have carbon 12, it means we have Polish 5 neutrons. Carbon 11 is going to be something like this. You put one more. Let's check whether it's stable or not. You can see that carbon 11 has the vibration at the heart of the center of the atom. So it's not stable. Okay. It's gonna be decomposed into smaller nuclei. Okay. So if you put one more neutron, when neutron exists, it's gonna mix or join the full proton together. If you put one more neutron, it's gonna be carbon 13. Carbon 13 is still acceptable. It's still stable. Okay, and because it has same neutron. But if you put one more neutron, when there are too many neutrons, the nucleus will no longer be stable. It has vibration like this. Okay, so it has divided. Carbon 14. That's why carbon 14 is has a decay like this. Okay. Okay, carbon 12 exists 9.9, almost 99%. carbon 14 is used in carbon dating. Hydrogen has 3 isotopes, such as, first one is called hydrogen. Sometimes it's called protein. It looks like a variation of proton, but it's already anatom, so sometimes it's called protein. And this one, H21, it's called deuterium. Duo means the number 2, right? When you have 3 nucleons or 2 neutrons, it's going to be called tritium. Tri means 3, right? Let's talk about the first variation of the hydrogen, and that's called deuterium. Deuterium is available in almost unlimited quantities from our lakes or oceans, and it's very expensive to extract. So if you want to do a business about the extraction of the sugar, it's going to be expensive. The tritium is even not stable. It's not very stable, so it's radioactive. It half-life of 12.3 years. So if you start with 1 kilogram of tritium, so you're going to end up with only half the initial amount by 12.3 years. Tritium will undergo speed of decay to helium-32. So one of the neutrons will transform itself to proton, and when we have an additional proton, it's no longer hydrogen, but rather helium. And helium would have a different behavior. It would possess different behavior than the hydrogen. Helium is inert gas, so it's already stable, so it would not do any chemical activity with other elements to be constituted as a molecule. So the tritium doesn't occur naturally, and it must be artificially produced. So if you want to find tritium, you can have it or build it up in the laboratory. Now let's talk about the nucleosides. When you know already the number of protons, the number of neutrons, and the number of nucleons, in the previous topic, we're going to consider the size of a nucleus. Of course, nucleus would be smaller than the atom, right? The whole atom, because an atom would also process the space of the electron movement or orbit. When we get it off electron, our center would process smaller area or volume. A common unit of length is called as the femtometer or Fermi. Fermi is the surname of Enrico Fermi, and it's defined as 1 FM. FM is not frequency modulation, but rather Fermi or femtometer. 1 femtometer is equal to 10 to the negative 15 meters. And several experimentalists reveal that most nuclei are approximately spherical and have an average radius that is given by R equal to R0. R0 is the constant, which is 1.2 to the 15, 1.2 femtometer. And A is the number of nucleons, right? But this is the third root, right? The power of 1/3. So, of course, when you can see that when you have more and more neutrons, the nucleus is going to have bigger and bigger size. So, but you can several designs. The size of nucleus will be bigger. Okay. The next one is that now let's talk about the density. Before we go to the density, we need to talk about the volume. Okay, because density is the mass with respect to or divided by the volume. As the explanatory suggested, the shape of the nucleus would be sphere, right? So the volume of the sphere is taken from 4/3 pi r cube, right? R is 3. And once you substitute this expression with the power of 3 on both sides, you're gonna have this. Okay. Pi r 0 cube and multiplied by the number of nuclei. If you have more and more the size would be much bigger. With this expression, you can see that V sphere is linearly proportional to the number of nuclei on the mass number. Okay, it depends directly on the number of nuclei on the mass number. Let's talk about the first element, and that's called iron. Iron has number of protons as 26, so it's a kind of heavy metal, right? Iron, and this is the mass number. Exit mass, 55.645. You can see that if you round this decimal number to the closest integer, it's going to be 56. That's the 56th isotope of the iron. Iron has the electron configuration like 3d6/4s2. It's the transition mean changed. The iron has had a good property to be shaken. Due to the oxygen, it's going to be oxide and we get rust and so on. Let's move to the next part. A is 56. Okay, as I told you, 56 is the closest integer to this number, so that's the size. First of all, we're going to need to find the radius. Radius is pi r 3 and a, right? Now that's volume. The radius would be found from constant 1.2 femtometer and A, which is the number of nucleons with a power of 1/3. So once you substitute the value of A, you should use the mass number, which is an integer, and this is already constant. If you use the template, you get this value. Okay. The next one is the approximate mass. Approximate mass. So what? The approximate mass means 56. And we neglect the mass difference between protons and neutrons because it has only very tiny effect. So the mass of the iron would be the multiplication of the mass number of M. The mass of a single nucleon, let's say, is mass of neutron. You make this multiplication, you can get 9.352 times 10 to -26 kilograms. And that is for mass of the iron. Now let's talk about the volume of the iron. So it's going to be 4 by 3 of Earth. And I R raises to 3 to the power of 3, and the mass number, just make this multiplication and get this one. And if you want to find the density, according to the typical definition, density would have the expression as the ratio between mass of iron and volume of iron. Okay. Mass of iron is what we have calculated earlier. You just leave it at the numerator, and the volume of the iron is right here. We just find. Leave it at the denominator portion, you're going to get the ratio and use the calculator to get 2.3 10 to 17 kilogram per cubic meter. So it's quite a lot. Okay. The density of the iron is extremely high, so that's why humans use this property from the iron in order to get the strong structure manifest. Nuclear force. Nuclear force is the kind of force that could exist inside the nucleus. Okay. Of course, according to the typical behavior of proton is a positive charge. It's a positive charge, right? Proton would attack electron, and that effect is quite is not so strong because electron is far away from proton. But the one that can have the strong effect to proton would be proton itself, or neutron would not do anything because neutron. Protons attack each other via the nuclear force. At the same time, they repel each other through the Coulomb force because you have the same type of the charge. Nuclear force is an electric force that acts between nuclear particles. These electric forces can exist between proton and proton, proton and neutron, and neutron and neutron itself. So it means if you have more neutron, you can get more electric force. But too many neutrons will also cause a problem because there will be vibration and the nucleus is not so stable. A bigger isotope would also be unstable. The interactions are approximately the same. There are two types in the nuclei. The first one is weak nuclear force. The second type is strong nuclear force. The strong nuclear force is about 10 times more energy than the repulsive electromagnetic force. It's stronger. Okay, if you have the electric force caused by the same type of neutron, same type of proton, this strong nuclear force is more significant than the typical repulsive force between positive charge like the proton and proton. Okay. Now let's move to the next one. Nuclear force is the short range force. Okay, this force will exist only when the protons stay very close to each other. And that's in the order of 10 to -15, and that's called femtometer, which is very small. Okay, they can fall down when the nucleons are separated by a few femtometers. So if you change only a few femtometers, that nuclear force will become bigger. The nuclear force become extremely repulsive if you put the nucleon to be too close to each other. Okay? So you should leave it in a proper distance. Okay, you're gonna get that force, and that nucleus will be stable. Now we arrive at the chart like this. On the y-axis, we're gonna have different values of the neutron. Along with the x-axis, that's different values of the proton. Of course, if you go to the right, the nucleus will be bigger and bigger, because and the elements will also change. Because you have different numbers of protons. The elements will change automatically. But at the same number of proton, you can have more neutrons or less neutrons. Okay, you can throw away neutrons from your nucleus, and it's gonna go down. The dots, black dots here represent the combination of appropriate protons and neutrons, and that's why the nucleus doesn't exhibit decay at all. It's gonna fall down to the smaller nucleus. It's not going to be transformed into different types of nuclei. And in the green, the black one represent the stable nuclei. And this line is called line of stability. The gray area would cover the unstable nucleus, and that's called unstable or radioactive nuclei, because it's going to emit the radio wave. Okay. The black dot line here represents the straightforward line when the number of protons is the same as the number of protons. They have equal proton and neutron inside. You can see that when the nucleus is bigger and bigger, because you have more and more protons, the nucleus will be unstable because you have too many positive charges. That's going to bring the repulsive force. So the nucleus is no longer stable. You need to have more and more neutrons in order to join them to stay together and to have more attractive force, and to try to combine those repulsive force from the positive charge by proton. That's why the gray area or the black dots here deviates from the typical line. A typical line or the equal line from proton is will be valid for this small number of proton or small elements. But if you have big and big, because your rule is not valid. This chart actually is called Sagre chart. It shows the neutron number and proton number for stable nuclei. Sometimes nuclei will be called nuclei. Okay, this is the word in chemistry, I think. Yeah. And the black dashed line represents the case when the number of protons is the same as the number of neutrons. In black dot points here are the nuclei that are already stable. Okay. But anyway, from the diagram we can make a conclusion a little bit somehow like this. The light nucleus are more stable if they can have an equal number of protons. One of the prominent example is the helium-4 You have two neutrons, two protons. The number of neutrons is even. The number of protons is also even. So this will give you a very, very stable nucleus. The nuclei will be long be stable within 5 and 8 is 8. The nucleus with a pair, because the nucleus is a pair of proton, pair of neutron, or alpha, doesn't really accept a fixed particle into structure. And a collection of 8 nuclei split rapidly into 2 nuclei. So if you have 8 nuclei, it's going to be split into smaller nuclei. Note also that there is no stable nuclei for Z=43, which is technetium, and Z=41 chromatin. Okay. This is the exceptional case. Heavier nuclei are more stable if the number of neutrons is greater than the number of protons. Okay. And more neutrons are needed to keep the nucleus stable. Okay. You need to have more neutrons in order to create the attractive force. Okay, this attractive force will try to combine the repulsing element that's called proton. And neutrons are affected by only the attractive nuclear force because there is no repulsive force, because neutrons will not push each other. And eventually, when the number of protons is equal to 83, and that corresponds to the mission. The repulsive forces between protons cannot be compensated anymore by adding the neutron. This will be the last atom stay in nature. Due to the short-range nature of the nuclear force, a given nucleon interacts with its few nearest neighbors rather than all nucleons in the nucleus of the neutron. Okay. Now let's talk about nucleus pairs. One proton would have the mass like this. Some physicists have measured the mass of proton, but because it's very small, it's tiny, very tiny, it's difficult to get the exact value of the mass of the proton and the neutron. Both have nearly the same value, but neutron would have a little bit more mass. Okay, and that's called on the order of 10 to negative 27 kilograms. Okay, the time is over. I'm going to need to collect all my stuff. See you next year, right? And good luck with your midterm exam. Bye bye. สวัสดีครับ
ความรู้พอสอบไปเชิญได้ครับเจอกันห้องนั้นครับ
หรือว่าพาราจะนักเล่นเกมต่อ
ก็เดี๋ยวไปห้องนั้นก่อนแล้วครับ
ไปห้องนั้นครับ
เดี๋ยวเราเลยชื่อก็จะต่อด้วยครับ
โอเคครับ
ตัวกล่าวที่ไหน
ฝากยกกล้องไปห้องนู้นหน่อยครับฝากยกกล้อง
มึงไม่เก่งมึงไปเล่นฟอร์มร็อบเล่นร็อบดีกว่าร็อบว่าร็อบไอ้เหี้ยร็อบมันพูดโกงว่าร็อบมันเก่งว่าฟอกเก่งกว่า
ฟอกเก่งกว่าแต่ฟอกมันเกือบมันเก่งกว่าท็อป 5 ในเกมได้อะมันแบบทุกตัวมัน
ร้อนบอดแคส
ฮะ
บอดแคส
บอดแคส
บอดแคสเก่งตัวไม่งูแต่ว่าร็อบโอ้ยเหี้ย
ท็อปมันโคตรเก่ง
กูยิงไม่เป็นสมอนร็อบยิงยังไงวะร็อบยิงยังไงยิงยังไงไอ้เหี้ยเอค้างแล้วต่อยรัวไอ้สัตว์ ไม่เอ็นครับมันอยู่ไกลๆห่างนี่เนี่ยมันอยู่ห่างจากตัวมันจะยิง
โฟกัสมึงไอติมยัง
เอาที่แม่เลยวะ
เนื่องจากไอติมฟรีเว้ย
เก็บตังค์กูไม่ชนะเก็บเชียร์นี่กูก็ไม่ชนะไอ้เก็บเชีย
เพิ่ง
ร์
เหยียบมึงเพิ่งอยู่อ่ะไอติมอ่ะ
เชียร์ใช่ไหมไม่ไหวเลยสอนหรือเปล่า
คอนเสิร์ต
มันต้องเล่นได้อยู่แล้วเว้ยลองลบเกมหมดไปอ่ะไม่ได้ลองหรือว่าไม่เอาทำไมได้แต่ไม่ว่ามันไม่ตลาดใหม่มันไม่แบบไม่เห็นไอติมไม่แกไอติมเอาไปนิดนึงเอานิดนึงนั่นนี่ละเฮ้ยต่อกำลัง
พอแล้วไอ้สัตว์
โอ้โหเฮียอะไรเนี่ย
ได้ทำให้ฝีมือเขาจะร้องว่าไม่ได้ครับได้แซงกันคุณจะสังสรรค์อะไรกันไม่ต้องเรียนใช่ป่ะก็แต่ละพักมากเป็นหมอหมอคนเดียวนะที่อยู่ในโรงพยาบาลนะคุณรู้ว่างานโรงเรียนเขาทำอะไรอ่ะเป็นมือกองแนะนำว่าจริงๆงานแต่งงานเขาอ่ะเขาตีกองเองอ่ะใส่ชุดเจ้าสาวด้วยนะแล้วก็อย่างนี้ใส่ชุดเจ้าสาวที่ตีกองอ่ะเคยเห็นหมอคนหนึ่ง โกงอะไรครับโกงอะไรโกงอะไรครับอันนี้โกงอะไรมามีอ๋อโอ้ยลูกนี้ผมจริงลูกผมอยู่ปริญญาตรีเลยพวกเนี้ยเข้าน้ำแป๊บครับเดี๋ยวมา
ยังไม่หยุดคาร์โบเกต เดียวกันสีที่มีผู้หญิงเดียวกันเดียวกันโอ้แต่ต่างอันนี้ไม่ใช่อันนี้อันนี้โอเคเอาเอาดิไก่เอาไข่เป็นก้อนเหมือนไก่ที่ปีกเด็กของเฮียเราเท่เราเฮียก็ไม่ได้เด็กมีค่ะสกิลพัฒน์ดีไอ้ยังนี่ก็เฮ้ยมันมีเฮียไอ้คนดาวตาเก๊กไอ้คุณก็เลือกไปดิมาบอลกูนเฮ้ยทะเลาะเฮ้ยไม่พูดดีกว่าเนี่ยยังไงเรือได้ไหมโอ้โหเฮ้ยอ๋อยังไงอยู่ต่อเลยได้ไหมสักทีพักสิไปไอ้ลุงก็มีแต่คนโปรยไปในหัวใจลองเข้ามาอีกลองเข้ามานานเลยก็คงต้องลาเพราะใจที่แหวกวายฉันไม่ว่าจะเธอได้เพียงสายตาอยู่ต่อเลยได้ไหมอย่าปล่อยให้ตัวฉันไปเธอจะรู้ทั้งหัวใจฉันอยู่ที่เธอหมดแล้วตอนนี้อย่าลืมคำว่ารักจะคำบอกลาเมฆฝนบนฟ้าลมรู้ดีคืนนี้ฉันไม่อยู่ใกล้ๆเธอเพราะว่าคืนนี้ฉันรู้ฉันจะนอนฝันร้ายและฉันไม่กลับไปไม่มีเธอเคียงข้างฉันนาฬิกาจะไม่บอกอยู่แล้วว่าของฉันที่ไม่มีเธอคงว่างเปล่าอยากอยู่ดูแลเธอฝันดีแต่ใจรู้ดีว่าหมดเวลาของฉันอยากอยู่กับเธอนานเธอคงต้องลารอใจที่ไว้วันอยากอยู่กับเธอต่อแต่ฉันไม่ว่าจะเธอให้สายตาอยู่ต่อเลยได้ไหมอย่าปล่อยให้ตัวฉันไปเธอรู้ทั้งหัวใจฉันอยู่ที่เธอหมดแล้วตอนนี้ได้ยินคำว่ารักแต่คำบอกลาไม่พ้นบนฟ้ารู้ดีคืนนี้ฉันได้อยู่ใกล้ๆเธอไม่ร้องอ่ะเอ็นก็เอาคนไปเอาไม่เฮ้ยเชียร์ไม่ดังเธอก็รู้ทั้งหัวใจฉันอยู่ที่เธอหมดแล้วตอนนี้จะรีบคำว่ารักเจ็บคำว่ารักไม่พ้นความฝันรู้ดีฉันได้อยู่ที่ใกล้ๆเธอคนน้อยต้องกูตอนไหนกูอยู่ที่ไหนเปลี่ยนด้วยกูรู้ว่าหมดแล้วเนี่ยสลักจิตกูไม่ได้ยังไงวะมึงนั่นแหละอันเบอร์สุดคือคิวต่อไปเลยอันล่าสุดเลยเนี่ยหลังจากโมงของโมเสสโมจะไปที่ยังมั่นใจแล้วไม่ก็ต่อไปต่อไปเรื่อยสลักจิตเดี๋ยวมึงก็รู้ไอ้สัตว์ทำไมเราเพราะปอมคูณไอ้สัตว์ก็เบรกยิงไม่ได้แต่ถูกเลยแต่เราไม่ได้เก
ว่าเราบอกแล้วไปกับคอนโดอ่ะหรือว่าไปใครยังไม่เช็คชื่อเลยจะกลับแล้วหรอไม่ก็เป็นเราเป็นเป่าคุยนะเว้ยตีกองก็เป่าแล้วก็เป็นเรื่องราวของเรามันควรจะตรงยังสวยงามต่อไปนะเป็นจะบุกร้องรอยความรักที่เธอได้ทิ้งมันเอาไว้ยังมีไม่เป็นเยี่ยในlet's talk about personnel inปานิธีครับปานิธีใช่ครับอินฟูทิพย์ครับอินฟูทิพย์ทิพย์ไปไหนอ่ะอาลาครับอาลาพรส่งไปร้านว่ะการตะกอนมาที่ลายการตะกอนลายจะวนอยู่ที่ไหนอยู่ถ้าเธอรับชิ้นจริงอ่ะเดี๋ยวลายการตะกอนไปต่างจังหวัดกับครอบครัวมาครับได้ที่สองมาครับนะครับได้ที่สองมาครับมาครับคุณ ไปแวะเวียนอยู่ห้องนู้นเนี่ยนะ
ใคร
ก็ศิลวิทย์
โอ้ my god
ศิลวิทย์โพลครับทีมสิงห์ครับทีมสิงห์นอนพักผ่อนนะเต็มวงนี่ไม่เคยอันนั้นว่างเลยนะจะเข้าวงกับเพื่อนเสมอเลยนะการกระทั่งตลอดมีทัศตะกี้นะเราว่ามาแล้วพิชนันครับพิชนันพันที่เดวิดโอเคเป็นท้ายไทยวันนี้ด้วยอ่ะเป็นได้หลายอย่างที่นะครับอยู่ที่ครับคณะวิทย์ครับคณะวิทย์ฮัลโหลคณะวิทย์ไปไหนแล้วคณะวิทย์
14ครับ
14คณะวิทย์
ครับมาครับ
นะครับสันดูดีรัตนะครับศิวปอนนัทพลแนวครับชยุทธพลนะครับโอ้ชยุทธพลคุณหายป่วยมาแล้วนะนะครับกรครับอยู่มุมครับอัมโชดครับอัมโชดฮะอัมโชดในทัพเบิร์ดเดย์แม่เพื่อนอยู่แล้วมีโอ้แม่เพื่อนด้วยแล้วเอาไงแอคเซนต์นะชานนท์ครับชานนท์ชานนท์อ่ะชานนท์เองเข้าน้ำครับกระบวนสิบตะกี้เห็นอยู่ไปห้องนู้นอ้วนเข้าน้ำ2 คนเลยเหรอจุฬากี่โมงจุฬาจ้าแก้วไม่อยู่หายไปไหนอยู่ไหนผมไม่เจอมีด้วยเหรอโอเคใส่ของแต่ละคนส่งมาคนเดียว605 แว่นอยู่ไหนอ่ะ604อ๋อโอเคพระราชแก้วโต๊ะคอให้ดีเยี่ยมยากทำกิจกรรมครอบครัวเลยครอบครัวมีกิจกรรมด้วยนะขอบคุณทีมากแล้ว
จะนอนก็แต่ถ้าไม่นอนไปนอน
นัทพลเองอยู่นี่ไปไหนแล้วอ๋ออยู่นี่อยู่นี่แล้วนัทดลจะอยู่ไหนแล้วโอเคอริยวุฒินี่ครับ
แจ๊ดกูนอนด้วย
บุริศักดิ์
แจ๊ดกูนอนด้วย
ไปวัดสันตพัฒน์นะครับเปิดมิวสิกวิดีโออยู่ไปทำคอนเสิร์ตอยู่แล้วสรุปชานนท์ไม่เอาใช่ป่ะชานนท์กมลสิทธิ์
ไม่ได้นอนเลยที่
อยู่ไหนอ่ะเป็นสูตรของ นะครับการนำเสนอ presentation หน้าห้องเนี่ยเพื่อให้นักเรียนมีความคุ้นเคยกับการพูดในที่สาธารณชนนะครับห้องนู้นบอกว่าผมอายครับอาจารย์ผมเป็นคนที่อายไงก็แล้วแต่ผมก็เป็นคนที่อายแบบคนสมัยก่อนเอาเลยสองคนนี้ครับก็ให้นักเรียนได้มีโอกาสนะครับฝึกการพูดต่อที่สาธารณชนนะครับให้มีความคุ้นเคยนะครับเกิดวันหนึ่งใครจะไปสมัครเป็นนักการเมืองนะนักการเมืองไปพูดขึ้นไมค์บนเวทีไอแล้วไม่ได้นะนักการเมืองต้องกล้าพูดนะครับเห็นปะให้นักเรียนได้ไปยืนพูดเพื่อให้นักเรียนได้คุ้นเคยครับว่าเรื่องคนที่จะพรีเซนต์งานครับเชิญเลยใครจะพรีเซนต์เรื่องอะไรมันจะมีคนที่ตกแล้วก็ไม่ได้แก้เลยวันนี้เราสุดท้ายเนี่ยไม่แล้วไม่ใช่ครับผมบอกสุดนี้สุดท้ายแล้วจะต้องส่งคะแนนเก็บให้โรงเรียนแล้วครับเอาไป0.0001คะแนนแล้วเชิญคนที่จะพรีเซนต์อะไรก็คืออะไรอย่างศิลปะคุณจะเข้าสถาปัตย์เหรออ๋อในช่างบ้านเล่นๆนะอ่านการ์ตูนมากครับหรือว่าไงอ๋อคนชอบอ่านการ์ตูนบ่อยเดี๋ยวอ๋อผมก็อ่านนะแต่ก่อนพวกโดเรมอนโนบิตะอะไรเนี่ยผมชอบอ่านฮะวันพีชเป็นไงวันพีชอ๋อเรา
ความฝันไม่ใช่เรื่องที่มันจะเอามาลองเล่นกันได้ไหม
ตามสบายครับ
ากาศมันไม่เหมือนเตรียมสอบกลางภาคนะมันเหมือนหยุดปีใหม่เฉยๆเลยคุณไม่ซีเรียสต้องมาเตรียมสอบอะไรเลยมันเหมือนแบบจะเป็นวันสุดท้ายของปีแล้วคุณก็แบบก็เหมือนฉลองอะไรแบบโอ้คุณเล่นคนนี้เลยเหรอใช่ครับโอ้สุดยอดมากเป็นแฟนแท้ไอเดียนี้ไม่เกิดเราได้รออยู่หรอยังมีอยู่แล้วตรงนั้นเป็นงานในหนึ่งยุ่งโอ้ยที่เนี่ยไม่ทำอ่ะไม่เอาใครมาฟังใครก็ไม่ได้ช่วยต่อยอยู่พวกมันที่กันหมดเลยเอาคุณมีเล่นเหรอผมนึกว่าคุณริศักดิ์เขาจะเริ่มก่อนเอาอันนี้ด้วยป่ะไม่ใช่คะแนนกลุ่มด้วยหรือว่าไอ้แย่ใช่ครับได้สิโอ้Hello. Good afternoon, ladies and gentlemen, and today I will present about eyesight. First, let's start with introduction. Isaac Newton was a pioneering mathematician and physicist whose work laid the foundation for modern science. His contribution to calculus and the laws of motion revolutionized our understanding of the universe. Next is the early life of Isaac Newton. Newton was born in 1643 in Worcester, England. He attended Cambridge University, where his interest in mathematics and astronomy flourished. And his early experiments with optics and lights laid the groundwork for his future discoveries. And the next one is laws of motions. Newton's three laws of motions are fundamental principles in physics. They describe the behavior of the objects in motions and lay the groundwork for the development of classical mechanics. His work in this area remains a cornerstone of modern physics. And this one is the universal gravitation. Newton's laws of universal gravitation explain the force of attraction between all objects in the universe. This groundbreaking theory provides unified explanations for celestial motions and laid the foundation for modern physics, modern astrophysics. And the next one is the optics and color theories. Newton's experiments with lights and prisms led to his groundbreaking work on the nature of colors. His theories of colors and discoveries of the spectrums of light revolutionized the views of optics. And the next one is the legacy in mathematics. Newton's development of calculus transformed the field of mathematics and provides a powerful tool for solving complex problems. His work in this area has had a profound and lasting impact on a wide range of scientific disciplines. And next one is influence on modern science. Newton's legacy extends far beyond his own time, influencing generations of scientists and shaping the cause of modern science. His ideas continue to inspire and guide researchers in diverse fields of study. And next, so we got Newton's principle. Several words. Roughly, national language principle, mathematics is considered one of the most important scientific
books ever published. It's laid the foundation for classical mechanics and remained a landmark in the history of science. And next one is the impact on societies. English contributions to science have had a profound impact on societies. From technological advancement to our understanding of the natural world. Its enduring legacy continues to shape our world in countless ways. Yep, and that's all. Thank you. Right.
So is there any question to Aliyawood's talk? Perfect. So how do you come up with this great explanation of you?
Actually, Isaac Newton is one of my favorite scientists because I love gravitational studies and also the law of motions. Very fun. Thank you.
Okay. So the next presentation.
เอาคุณจะต่อเหรอ
ได้15 นาทีครับ15 นาทีโอ้ไม่ถึงจังโอ้ต้องถึงครับแล้วถึง15 นาทีนั่นไงถือว่าถึงรอบการเล่นอ๋อเฮ้ยอันนี้อาวุธใหม่อ่ะใหม่ที่อ๋อ
Alright, my name is from 604&M609 on Kappa Hazard. Today I'm going to present to you about Galileo's performance. Hold on. Okay, so let's get started. Good afternoon, everyone. Today I am honored to present to you the life and contribution of one of the most influential figures in the history of science, Galileo Galilei. I think everyone right here has already known that he's the one who invented the telescope and discovered a lot of important information about our solar system. Okay, so first the introduction. Unveiling the brilliance of Galileo Galilei, one of the history's most remarkable scientists. His groundbreaking achievements revolutionized our understanding of the cosmos and laid out the foundation for modern physics and astronomy. Let's talk about his early life. He was born in Pisa, Italy in 1564. He showed an early aptitude for mathematics and science. His curiosity and innovation were evident from the young age, setting the stage for his future groundbreaking work. About his conflict and the church. Okay. Galileo's support for the heliocentric model brought him into conflict with the Catholic Church. His advocacy for ideas of the Copernicus led to his trial and imprisonment, despite his work laid the groundwork for modern astronomy. And about the telescope discoveries, Galileo's support for the heliocentric model brought him into conflict with the Catholic Church. Sorry. Okay, let's start about the telescope discovery again. Galileo's inventions of the telescope in 1609 led to the numerous groundbreaking discoveries. He observed a craters on the moon, the 4 largest moons of Jupiter, and the phases of Venus, providing strong evidence for the heliocentric model for the solar system. Okay, next, the legacy. Galileo Galilei's legacy is indelible. His insistence on empirical evidence and his advocacy for the scientific method paved the way for the modern physics inquiry. His discoveries continue to inspire and inform our understanding of the universe. The dialogue concerning of the two-shaped world system. In 1632, Galileo published his most famous work, the dialogue concerning the two-shaped world system. This book presents the arguments for the heliocentric models and the geocentric wheel, leading to further and his eventual. So let's talk about the impact on modern physics. Galileo's contributions to the understanding of physics and astronomy are immeasurable. His work laid the foundation for the scientific revolution and continues to shape our understanding of the cosmos. And his influence is felt in every corner of the modern physics. And for the conclusion, Galileo Galilei's achievements were truly remarkable. His groundbreaking work with astronomy and physics revolutionized our understanding of the cosmos and laid the foundation for modern physics. His legacy continues to inspire and inform the scientific inquiry. So thank you. This is my presentation.
ได้เลยครับเอาเลยครับยังไงก็ได้ครับต่อเก็บยังเอาไว้ให้ครับ 15 นาทีครับ 15 นาที
ต้องประมาณ15 นาที
Hello, my name is Hello, my name is Channel Gate number 22, and today I'm gonna present about relativity theory. So first, let's start with the impact of the theory. First thing, this theory is a revolutionizing the physics world. Why? Because the theory change the understanding of the physical world and pave the way for modern physics. And second is a foundation for future discoveries. This principle of relativity continues to shape our scientific exploration and technological advancement. The third one is that it is a legacy of the Einstein, one of the legacy of the Einstein. So let's introduce about the theory. First thing that the relativity theory is a theory developed by Einstein to explain the fundamental principle of space and time and gravity. The second is that the importance of it is that it's revolutionizing and understanding of the physical world and laying the foundation of the modern physics, as I said in the first slide. The key concept of the theory is that space and time dilation, length contraction, and the equivalent flow. So the principle, the theory divided into two theories. First one is the general relativity, and the concept of it is that the gravity as a curvature. As an energy curve, the curve like a curve of space and time, causing gravity. Second is that equivalence principle. Gravity is indistinguishable from acceleration in a gravitational field, and it can predict the motion of an object. General relativity accurately describes the motion of planets, stars, and galaxies. So how can we implement the theory into our modern science? First is that we can use as a scientific research. Relativity theory continues to inspire groundbreaking research, physics and cosmology. The second one is that can be applied in space exploration. General relativity plays a crucial role in understanding the behavior of celestial objects and planning space missions. The third one is that technological advancement. Relativity theory has led to the development of various technology like GPS, satellite, communication, and particle accelerators. And another big application of the general relativity is that on a gravitational wave, black holes, and cosmology. The second principle of the theory is that is special relativity. The principles divide into three parts. First one is the principle of relativity, which is the law of physics are all the same for all observers in the uniform motions. Second one is speed of light. The speed of light is constant of inertia frame of science or of reference. The third one is time dilation. Time slows down for object moving relative to an observer. The application of the special relativity is that it can be used as a GPS navigation. The correction for time dilation is crucial for accurate GPS calculations. The second one is that particle accelerators. Special relativity help in understanding high energy particle collisions. The third one is satellite communication. Linguistic effects are considered for precise data transmission. So, take a quantum leap into the relativity theory and unlock the secret of the universe. Thank you very much.
So what is the difference between general relativity and special relativity?
So the general one is that it talks about the curvature of the arm, but in the advanced one ของเรื่องเขาชื่อว่า A special relativity is that it's talking about the motion of the observers and the observer and the motion of it, which can sometimes be dilation of it through the speed of light or anything else. Do you have any more questions?
Silhouette question.
How is both general and special relativity related to, let's say, data transmission? So you said that relativity is related to data transmission, right? To the GPS and how we navigate. So like further exploration into such a concept, like maybe the rationales behind your talk seems to be quite stable or something. So it would be nice if you could guide us. Thank you for the clarification.
So we'll ask about how the GPS would work. So it can give you an accurate location by sending a signal to the satellite and going down, which the relativity theory takes part in it, as we have to use a satellite communication or data transmission. Yes. Thank you. What?
One clock at the International Space Station and another clock right here on my wrist. Which one will tick faster and why?
So in the International Space Station will be faster. Yes. Thank you very much. Any more?
Is there any more presentation? มีใครอยากพรีเซนต์อีกไหมไม่มีแล้วนะหมดสิทธิ์แล้วนะ
มีเซ็นซ่อมเหรอ
ฮะ
มีเซ็นซ่อมเหรอ
ใช่ ซ่อมหรือว่างานกลุ่มน่าจะหมดแล้วมั้งห้องเนี้ยไปกันทุกคนแล้วนะครับงานกลุ่มนะ If not, then we are gonna start the second chapter. ไปขึ้นบทที่7แล้ว Okay, the second chapter talks about it deals with nuclear physics and particle physics. Two things in the same chapter, but raw matters are quite related to each other. Well, we will start with the first subtopic, and that is so kind of nuclear physics.
taken from the book number 1 and book number 2. There are several subtopics such as nucleosides. Okay. In the previous chapter, we discussed something about the behavior of electron, the location of the electron, and how the electron is allocated in the orbit or shell. We saw the result of electron motion from higher energy level to lower energy level in photon. We have calculated some we have calculated the wavelength of the photon in some scenarios. Many stuff regarding the electrons. Now we move to the center or the heart of the atom, which is called nucleus. When we go to the nucleus, the physicists believe that there are mainly two particles, which are neutrons and protons. So there are many aspects to study. So the first one is nucleoside. So how big the nucleus is. Of course, the nucleus has much more, has much less space than the whole atom. So the size of the nucleus is around 10 to 15, or the spatial word for that is called femtometer, right? Or in abbreviation is going to be called Fermi, which is the surname of Enrico Fermi, Italian physics. And the next one is nuclear force. We will not go into detail about calculating how much the force is, but we would rather see the types of the force, whether it's attractive force or repulsive force, and how the nuclear force behaves due to different types of particles, like between proton and neutron, or between proton and proton, or between neutron and neutron. So that's nuclear force. We will see also two types of the nuclear force, such as weak nuclear force and strong nuclear force. And we move further on to the nucleus mass. Of course, at this title, you can determine the density of the nucleus. It turns out that the value of the density of each heavy metal element would be extremely large. So that means those metal elements are very strong. And that's why human made use of metal for constructing many structures like bricks or building. And once you get into the nucleus, then you can calculate the density, because if you know the volume or from the nucleus size and the mass, you will simply able to find the density, which is the ratio between the mass and volume. And one thing, when we get into the detail, the physics found that there is defect mass, or the mass laws, and Albert Einstein was the guy who discovered that the laws of mass turns out to be the binding energy, which is the energy that tries to attract several tiny particles to stay together as a nucleus. And then we're going to see the radioactivity, which is the behavior of the nucleus or the nuclei that are not stable. Okay, whether it has too many neutrons or too many protons. Okay, you can get several kinds of radioactivity. The first feature is the decay, because the composition of the big nucleus into smaller nucleus, there will be the rates of decay, right? And that can be measured in terms of how many nuclei per time each isotope would get reduction. Okay, the first type is the alpha decay. Okay, that happens when we deal with big nucleus like uranium or radium, and then alpha decay is something about the alpha particle, which is actually the nucleus of the helium-42. Helium-42 is the very stable nucleus in the universe, and we move to the smaller particle emission. That's called beta decay. Beta decay is actually the electron emission. The electron emission, or it's called beta minus. Okay, we will see the beta part of atmosphere when the emitted particle is not electron but rather positron, which is the antiparticle to the electron. And the most dangerous one is gamma decay, because these photon decay contains a high energy level that can destroy human tissue or human skin easily. And one last thing, which is carbon dating, is also useful. It's a kind of application from physics that humans try to use, because when we study something about unstable isotope or the nucleus, there will be decay rates. And once the physics apply decay rates to an interesting object, whether it's Pharaoh or human dead body, whether you want to check how long that body has taken, you can use this concept, because when we talk about the carbon, there are several isotopes of carbon. Carbon-14 is the most useful one in carbon dating, because the typical carbon will be carbon-12. Okay, we have 6 neutrons and 6 protons, and that's the most stable version of the carbon. But carbon-14 also exists from the transition from another element which is close to carbon, and that happens due to the cosmic ray from the deep space when it hits the Earth atmosphere. That element is transformed into carbon-14. Carbon-14 isotope is not stable, so there will be always decay of that nucleus. And carbon-14 get absorbed from the atmosphere on Earth, and the planet absorb the oxygen of several gases from the atmosphere. And the animals just took or have animals have the plants or the grass, and it absorbs automatically carbon-14, and human again eats the animals eat. So the carbon-14 is flown into our human body. Once we die, during the living period of human, there will be always exchange between carbon-12 and carbon-14 from the carbon dioxide gas. But once our body has passed away, there will be no longer exchange between carbon-14 and carbon-12. So the amount of carbon-14 will get more and more reduction. And the physicists use this idea to determine how long that body has already lost. Okay, that's the idea from carbon dating. The next one is nuclear reaction. This is the human determination when they bombard, means when they accelerate a particle to hit a nucleus and they want to get new elements. Okay, this idea was quite popular in the past because gold is the most precious element on Earth, right? And chemists try to convert any element to gold because gold is expensive and you can get wealth from this chemical process. And also nuclear reaction is another result from that attempt from the chemist because when you project or accelerate a neutron to hit the nucleus, you can get new result like a new element or a new particle, and that's called nuclear reaction. In this kind of thing, you can have two types. The first one is called nuclear fission, which is the composition, the reduction of the big elements, big nucleus to smaller or few smaller elements such as barium or something. And nuclear fusion is the opposite process. When you have light or small elements, you're gonna convert it. Okay, the actual purpose is to get energy right from that nuclear fusion, but the outcome will be the bigger element or bigger nucleus. And that's all for nuclear fusion. We're gonna see in this chapter. Let's talk about particle physics. It has basic idea to what's going on inside the nucleus. We will talk about the four fundamental forces that exist in physics. Standard model of elementary particles. This is what you have. This table is what you have seen earlier in the previous chapter. And then we will talk about the first group of fermion that's called quarks, and the second or the lower group which is called leptons. Okay, we would do something about the lepton number. Okay, it's a kind of balancing the equation in lepton, and the bigger type of particle is called hadron, which includes mesons and baryons. Those are bigger particles that play some role in certain specific area in physics. Okay, nuclear physics. What is the meaning of nucleus? Because nucleus is the core or the central part of the atom, right? And it usually has a round shape, whether it's exact sphere or almost sphere. And what is the difference between nucleus and nuclei? Nucleus is a singular word, and nuclei is the plural form of nucleus. In chemistry, sometimes they call nuclei as nuclei, not nuclei like this. Nucleus is a collection of particles, mainly of two types, such as protons and neutrons. You know that proton has a positive charge and neutron doesn't have any charge, but it's called the neutron. Nuclear is another term which is used to refer to as whether it's proton or neutron. The general term would be called nuclear. Okay, like this. And the symbol for the nucleus is like this. Okay, there are four letters to four alphabets to represent one or six. Sometimes in certain area when you work every day with that element, okay, the number one, the last number, the second number, which is the number of protons, can be negative. Okay, because when you represent write x at a certain alphabet, you can imply that that element would have specific number of protons. The upper left or the superscript left on the left side is mass number. Of course, when the ending is number, it means that number should be an integer, and also mass number is an integer. It's the number of nucleons, how many protons together you have in the nucleus. That's called the mass number. Please note that the mass number cannot be a decimal number. Okay, it's only an integer. In one of the most important things is the atomic number, and that's called Z. Okay? Z is the number of protons. Okay? When you have different value of atomic number, you have also different atoms, and that's why they call atomic number. The number that identifies a certain atom. And the last one, which is actually redundant, okay, is called neutron number, which is denoted by N. N is equal to the number of neutrons, and usually you can find the number of neutrons by subtraction. Okay, the subtraction between the mass number, the number of total nucleons in the nucleus, and the number of protons in that element. N equal to A minus that. We go to PHET, right? Suki would be the guy who is more expert about the constitution of the nucleus, like this. Okay. But I would like to apologize for the language here. It's shown in German because everything here is written in German. Okay, the first thing that you can view as is that it's impossible to have a neutron. A neutron would not give you an atom or a nucleus. It's only a particle, okay? And that's why you can see the vibration of the neutron. Neutron is not stable actually. Or in terms of a cloud, it's going to be something like this. With the motion and electron orbits, you can see like this. So neutron is not stable, but what happens if you put one proton? It's going to be stable, and this corresponds to the nucleus of hydrogen, right? But in German it's called Wasserstoff, which means hydrogen. Okay. Wasser means water in German. Stoff means stuff or something. Okay. But it doesn't directly imply hydrogen, right? It means the stuff that you can use to build up as water. Okay. But the actual meaning in English is called hydrogen. Okay. You can see that if you put only a single piece of proton, the whole atom remains an ion. Okay, it's not neutralized. You have only the positive charge here. You need to put one or single negative charge. It's gonna become a neutral atom. Okay? It doesn't have any positive charge or negative charge. Okay. จุลวิทย์จะแนะนำเพื่อนเล่นนี้ไหมครับผู้เชี่ยวชาญแนะนำไหมครับไม่เคยเล่นนะครับโอเค Yeah, you can build up the nucleus from this application in this type of application. And it's gonna be identified on the periodic table immediately once you put many particles into the nucleus. So yeah, it's a good way. And as you see here, here is the number of nucleons because we have only a single proton. That's why the A number, which is the mass number, means number 1 because we have only a single nucleon. And also the number 1 here is the number of protons. Of course, we have only a single proton, and that's why this number is number 1. This alphabet will correspond to the name of this element, and that's called hydrogen. Okay, or in German it's called Wasserstoff. If you put one more, if you put one more neutron into that, this one will turn out as H21. H21 means you have 3 nucleons in the nucleus, 2 particles in the nucleus. And you have a single proton in the nucleus. Number 0 means you don't have any charge at all. Okay. If you have 1 plus here, it means you have 1 electron missing. Okay, that's why 1 charge is dominant. When you leave the electron here, it's going to remain as neutral. Okay? If you move the electron out of this arrow is going to lead down to the positive side. It has 1 positive charge. Okay? If electron is weak, it's not if you put one more, this one is an isotopy hydrogen. It's called deuterium. Deuterium can be used in the real world as heavy water. Heavy water is used to cool down the reactor in the nuclear power plant. Okay. The reason behind is that typical water would not have enough stuff in the nucleus. When you have something more heavy or heavier than the typical water, it can absorb more heat or energy from the nuclear reactor. And that's why the people use the heavy water to cool down the nuclear reactor with more efficiency. Okay. And what is the specific word of the hydrogen when we don't have the neutron? Of course, the typical word would be called hydrogen in English, right? But the specific word for what is the specific word for it? It looks like the word that Intel has used it as their CPU name. You know, hydrogen, when it doesn't process it doesn't have the electron, it's gonna be composed of only proton, right? And the special word is derived from this word. It's derived from proton. It's called proton. Yeah. Okay. When they don't have electron, the remaining stuff is only proton, and the specific word for this isotope is called proton. But when you have one more neutron, you cannot put one more proton together, right? Because if you leave one more proton, the number of protons changes, and you don't have a single proton anymore. The element changes from hydrogen to helium. And when you have two protons together like this, what is the reason why they have vibration like that? Yeah, they pair each other, they have a repulsive force. Okay, because both are positive charged, and from the Coulomb law, there will be repelling force or repulsive force. Okay, that's why they have vibration, which represent the unstable condition for this type of Okay, let's talk about the deuterium. Okay, deuterium is the case when you put one neutron to the hydrogen nucleus. If you put one more neutron, what is going on? What is going to happen? Oh my God! It vibrates again. It's not stable. Okay, is there any specific word for this type of isotope? It's called tritium because you have 3 particles right now. The part of the atom, okay, so it's called tritium. Tritium is not stable. You can have it mainly in the experimental, spatial experimental room. Okay, yeah. Okay, yeah, it's not stable, but what happens if you project one proton into it? It becomes helium because you have 2 protons, and the nucleus remains stable, easy, like this. Okay, it doesn't vibrate at all. Okay, the nucleus doesn't vibrate at all. And one more thing is that the number of nucleons is 4 because you have 4 particles, 1, 2, 3, 4. And you have 2 protons, the number of orange ball is 2, right? Yeah. And you have also 2 dust. What does that mean? It means these atom is positive charge, Y2 plus. Yeah, usually when you have 2 protons, you should have also 2 electrons, but we don't have electrons at all in this structure, so we are mixing 2 electrons are missing in this figure, so that's why we have 2 plus. So is it possible to throw away 1 neutron out of this nucleus? If you remove 1 neutron from this nucleus, it's gonna still remain stable like this. 1 neutron is enough to handle the repelling force by 2 protons. And this is called helium-32, okay? Helium-32 is what you may find in the nuclear fusion, but most of the time you will see mainly helium-42, which is the major particle that exists in this shadow. Okay, okay, this one, okay, helium-42 is one of the most stable nuclei in nature. Okay, and if you want to remove the constituent ion charge, you just need to leave the 2 electrons, and you get 0, and now it becomes the complete atom. Let's get back to our lecture notes and get the idea of the nucleus symbol, right? Now let's talk about aluminum. Aluminum 27. You have aluminum has 13, right? Get back to the aluminum is right here. Okay, and then you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It means we need 13 protons to be constructed as the aluminum. Okay, let's throw away proton 13. 13. 11, 12. Oh, no more. Oh my God. ไม่มีให้อีกอะทำไงอะผมเลยโชว์อลูมิเนียมให้คุณไม่ได้เลย It reaches only neon. Impossible. My God.
ไม่มีให้ไม่เป็นไรมีไม่ถึงนะครับมีโปรตอนมีไม่ถึง no problem yeah aluminum 27 is the element we have 27 nucleon the number of particles in the nucleus is 27 and the number of protons is 13 okay usually when you work every day with the nuclear symbol, you can memorize the number of protons from the name of that element immediately. So sometimes they omit only make the representation of that number on the subscript on the left. Okay, they simply write aluminum 27. Okay, the nuclei of atoms of particular elements must contain the same number of protons. Okay, this is the basic. It may contain different numbers of neutrons. Okay, neutron is somehow a freedom element. And you see the purpose of the neutron later. 4 atoms of carbon. Of course, carbon can be carbon 11, 12, 14, 14. Let's see how the nucleus of the carbon is. Carbon, right? We have carbon has 6 protons, right? 6 protons like this. Of course, they are totally 7, sorry. 6, right, like this. Carbon 11, what is that? We need 5 neutrons to the nucleus, right? This is carbon 11. What do you think then? Is this isotope stable? It's not stable. It has always vibration. So, Polish stuff ก็คือสตัฟที่ใช้ทำโคลก็คือถ่านหินนะเข้าใจปะคนเยอรมันแปลเนี่ยแปลซับซ้อนปะก็คือสตัฟที่ใช้ทำโคลก็คือที่คุณเป็นถ่านหินน่ะนั่นคือคาร์บอนนะคาร์บอนไม่ไฮโดรเจนไม่เรียกไฮโดรเจนเรียกว่าวัตถุสตัฟก็คือสตัฟที่ใช้ทำน้ำโอเคว่าแปลกว่าคนเยอรมันเขาเรียกชื่อแปลกๆเอาอ่านแล้วผมขอโทษด้วยมันไม่ได้เป็นภาษาอังกฤษมันลงตามภาษาของ iPad เลยคุณก็ได้ทราบเรื่องราวภาษาเยอรมันเพื่อแปลกคำๆไปนะแล้วก็ครูเราของภาษาเยอรมันจะไม่ลง S นะเขาจะเติม ES มันจะเป็น S มันคือ S ในภาษาอังกฤษที่เป็นครูเราคนลงชื่อแรงจีนไม่มีเพศจะมีเพศด้วยเหมือนกันเลยรู้สึกว่าของพวกคีนนะครับพวกที่มันจะตกใจรู้สึกว่าจีบคือได้คือมันจะหาเป็นวิสุทธิ์มันก็จะหาคนที่เก่งทุกความหมายคืออันนี้มันเป็นสิ่งที่ผู้เชื่อว่าหลายคนก็มีผู้ว่าหลายคนมีหัวประมาณนี้ Okay, you can see that carbon 11 is not stable. It's a kind. It's one of the isotopes for the carbon. It's not stable. So how is it related to our daily life? We cannot find carbon 11 easily in our daily life because it's not stable. Let's put one more neutron. We cannot change the. You cannot put one more proton, right? It's going to turn to the next element. When we put one more neutron, we have carbon 12. Okay. At the moment, there is no vibration, so it means carbon 12 is stable. And this is the isotope that we mostly find in the nature. That's carbon 12. Everything like wood, like this, okay.
And let's talk about the next isotope, which is carbon-13. It's still valid. It's still still right. So it's still stable. And what about the next one? Carbon-14. You can see that it's not stable. It's no longer stable when you put more neutron. Andอันนี้มันก็เรียนเหมือนกันเลยช้าใช่มันเราตายแล้วก็ยังแบบไม่ลดเท่าไหร่แค่นั้นก็กรุงศรีอยุธยาหรือว่าพ่อขุนรามยุคพ่อขุนรามอะไรประมาณนั้นนะถึงจะลดไปครึ่งนึงอ่ะคือมันไม่เสถียรแต่ว่ามันก็ไม่ได้หมดลดขนาดพันธุ์ทันใดนะก็นานๆลงโดนแตกไปแล้วกลับมาเอาเร็วๆไองานโอเคยังไม่ถ้าวันศุกร์you can see carbon-14 carbon-13 is still stable in nature but we can see clearly okay and carbon-14 is unstable but half-life is quite long so we can still find we use carbon-14 in counting the time or the age of an ancient object. And this process is called carbon dating. Okay, the next isotope, which is quite common to us, which is also important, is the hydrogen. And the first one is called hydrogen. The special word for the hydrogen one is protein, right? The next one is deuterium. Is used for cooling down the nuclear reactor. And next one is tritium. I'm not sure whether if you project one more neutron to this is possible or not, but I have to confirm all this information. หมดเวลาแล้วขอโทษเชิญเลยครับไปครับ See you next year right ให้ประสบการณ์สำเร็จกับข้อสอบการหน้าแต่เดี๋ยวผมก็ต้องมาเรียนอีกมาเก็บข้อสอบคุณครับไปเป่าคุยใช่ป่ะวันนี้ไม่ได้ยิงขันเราโดยกินกล้วยเลยนะครับเล่นแบบที่เราเล่นแบบนั้นทีมสีได้เลยสุดยอดมาก
ชวนมาดิแล้วส่งลิงก์ไปในสนามบินไม่ส่งไม่งั้นมันจะไปแข่งได้ยังไงหาเดี๋ยวนี้ไก่มึงไปขอเงิน82 บาทต่อคนเดี๋ยวนี้แล้วไปตอนนี้เลยเพราะว่าอีก
เอาลูกซูดเหรอต้องไปนั่งดูก่อนครับใช่ครับฉันก็ไม่แปลกเลยที่น้ำไม่แข็งไปแต่เล่นโคไม่ติดเวสไม่มีอ่านให้หมดนะอ่านถึงเรื่องอะไรอ่ะกุลาโมเมนตัมอะไรพวกนั้นครับอ่านให้หมดถึงการสุดท้าย
ทำไมมอเล็กๆพวกมอต้นเขากลับบ้านกันแล้วในขณะมอคุณยังต้องมีเรียน
ผมก็บางพวกเขาก็เลิกกันแล้วครับ EP เขาจัดไว้อย่างนี้
ให้คุณอยู่เรียนๆหน่อยEP แต่ก็เดินเยอะเลยต้องอยู่โรงเรียนนานหน่อยใช้บริการโรงเรียนเยอะหน่อยผมเห็นแล้วพวกมอต้นๆอ่ะเดินออกไปแล้วดอกรั้วไปแล้วบางที
สวัสดีครับเชิญ
สวัสดีครับอ๋อบ้านอันนี้เป็น2 ห้องเลยนะไม่ต้องเก็บกลับใช่ป่ะของเพื่อนอ๋อเป็นทั้งหมดเลย
ชาร์จอัดคลิปเลยเปล่า
ปิดเลยได้